Hey team, I'm Maddie. Welcome to ScienceSideUp, and today we're going to talk about 5G networks and how we can be confident that they are perfectly safe. In doing research for this video, I dug around on the internet for a while and I tried to find really the basis for the concern or the theory that 5G cellular networks are going to cause harm to people or are dangerous in some way. And I really never found anything that was like scientifically grounded enough to make a solid presentation against. But one of the concerns that I did see come up a lot that I thought was a really fair concern was, well, these networks haven't been tested, so how do we know that they're safe? How can we have confidence that they're safe? And so that's what I wanted to talk about how I can stand here with absolute confidence and say, nope, 5G network, all cellular networks, perfectly safe. So a cellular network works fundamentally the exact same way as a radio, right? The radio in your car. Both are going to transmit and receive data via electromagnetic waves. To really understand 5G, we need to look at the whole electromagnetic spectrum. So I've got that up on the board here for you. And that's over here we have our radio waves, microwaves, infrared, visible light, UV radiation, X-rays, and gamma rays. So one thing that's really special about light is that the speed of light is a constant. So the speed of light is equal to wavelength times frequency. We represent wavelength by the Greek letter lambda and frequency by the Greek letter nu. So since the speed of light is constant, that means I have a set relationship between wavelength and frequency. And then we have our second equation here. This is the equation for the energy of an electromagnetic wave. And the energy of an electromagnetic wave is equal to Planck's constant times frequency. The thing that's important about Planck's constant here is just that it's a constant. So the energy of any given electromagnetic wave is just a function of frequency. So if we look back at our spectrum, we can see that we've ordered it from our very long wavelength radio waves here on the left-hand side, at least my left-hand side, over to very, very short wavelengths for gamma radiation. And then the long wavelength of a radio wave is then associated with a very low frequency, because for the speed of light to be constant, if wavelength is big, frequency better be small. So my long wavelength means a low frequency, and a low frequency means low energy. So on the left-hand side, where we have all of our radio waves, we know that those electromagnetic waves are low energy, low frequency, long wavelength. And then here on the right-hand side, we have incredibly short wavelengths associated with really high frequencies, and then incredibly high energy. So there are two ways that an electromagnetic wave could do harm to a human being. And the first has to do with this high energy electromagnetic waves. Another word for that is ionizing radiation. So I did a whole video on this before. It's called Bruce Banner Would Have Just Died, and I'll put a link to that in the description below if you want a little more in-depth. But in less than a minute, the concept of ionizing radiation is that this is an electromagnetic wave with enough energy that that wave can give its energy to the electron, an electron orbiting an atom, and then that electron takes that energy and turns it into kinetic energy. And so that electron is freed from the atom. And now that takes a lot of energy to free the electron. So that electron is now free, and it's over here running amok, and it's left behind a positively charged ion. Both the electron and the positively charged ion can now go run amok inside your body, basically doing chemistry where chemistry isn't supposed to be happening. And so the only ranges of electromagnetic waves that have enough energy to be considered ionizing radiation to cause that process are UV, X-ray, and gamma radiation. 5G and other cellular networks live way down here, where I've marked like that big bold pink line. So they don't have enough energy to be considered ionizing radiation. They don't have enough energy to do what gamma rays do. So we know for sure that 5G can't harm us the same way that sunlight can harm us or other types of high energy radiation. So check, 5G can't harm us in that primary way that electromagnetic waves can harm living tissue. But there is a second way that electromagnetic radiation can potentially cause harm to living tissue, and that has to do with a really specific frequency band in the microwave range. So this is a microwave range that your microwave in your kitchen operates off of. And how that works is that it's electromagnetic waves that have a wavelength approximately the same size as a water molecule. That's about 0.3 nanometers, 0.3 nanometers. Very tiny, very, very tiny. We talked about the importance of the size of the wavelength relative to the size of what that electromagnetic wave is interacting with in the video where we measured the speed of light. So I'll link that below too if you want some more information on it. The basic idea is that if an electromagnetic wave, if its wavelength is approximately the same size as the thing it's interacting with, then it can cause that thing to vibrate. So the electromagnetic wave comes in, it causes, if this is my water molecule, it would cause it to vibrate kind of like this. And so this vibration, this kinetic energy, is then turned into heat energy, and that's what heats up your food. So if I put my hand in front of an intense microwave source and I just held it there for a very long period of time, my hand would get a little warm, and that's kind of it. In theory, if I held my hand next to an intense microwave source for a very long period of time, it would eventually do damage to my hand. But it would have to be a really, really, really intense source. It would have to be, my hand would have to be incredibly close to the source, and I would have to just stand there like this while my hand started to feel warm, right? Before it did like real damage. And so that's the second way that an electromagnetic wave can do damage to living tissue. How much of the video is she gonna do holding a slinky? More than necessary. What about 5G? When I was researching for this video, I tried to find the specific frequency range for 5G, and unfortunately, like every source I looked at had a different value for like the high end of the frequency range. And that's kind of what we want to look at, because we know that way down in the radio range, which is where the low end of a cellular network signal is going to be, it's going to be in the radio range, that's not going to cause us harm, right? We know that. So I wanted to look at the high end, and those numbers varied from source to source. But the biggest number that I found was 300 gigahertz. Now, that was actually much bigger than the other sources. They all said something like 50 or 60 gigahertz. But let's use the 300 as this high-end, max level, whatever have you. So 300 gigahertz is actually technically in the microwave range. So does that mean it's harmful? Well, no, because 300 gigahertz corresponds to a wavelength of about a millimeter. So a millimeter compared to the size of a water molecule would be kind of like comparing me to the size of the Earth. They're not comparable. The Earth is huge compared to me, right? So a millimeter is huge compared to the size of a water molecule. So it's 5G, the high end is going to be like here, and it's going to miss that range where you have the balance between energy and size and wavelength that can allow for water molecules to vibrate. Okay, so check, it can't affect us that way. But what about can it affect something that's a millimeter in size? Well, it can interact with it, right? But because my wavelength is so much bigger, right? A millimeter is huge for a wavelength. That wavelength is so big, that means it has to be, relatively speaking, that's a low frequency. So that's low energy. So a 5G network, even at that gross overestimation, highest end range, an electromagnetic wave produced at 300 gigahertz just won't have enough energy to make something that's a millimeter in size move or notice that it's being affected in any way, shape, or form. The only thing that would happen would be if you have something that's about a millimeter in size that's made of a conductive material, say like an antenna, then the electrons in that conductor would move a little bit. And that's it. The same way the electrons in your car's radio antenna move a little bit, and that's how you get a signal to your dash and you get to listen to Lady Gaga. So that's why 5G is safe in a nutshell. So if you guys have any lingering questions or concerns about 5G, please put them in the comments and I'll respond to them as quick as I can. If there's a specific source you want me to look at, I'm more than happy to do it. It just might take me a little bit longer to get back to you because I want to give you like a good answer. Okay, team, that's all I have for you today. I hope you are well and staying safe. Be sure to like and subscribe, and I will see you guys next time. Okay, bye, team. What's this? Everything's already written on the chalkboard. It's almost like I filmed this whole video only to discover in editing that my braid kept hitting the microphone and ruined all the